because it's a kind of a quick lesson, it'll help you out today, keeping things a little shorter. Nothing you need to submit for me today, but you will have some practice with these ideas tomorrow. So you definitely want to write down what we're doing so you can go back to it and look back at these examples so you have a pretty good sense of how to get this thing done. Let me just grab my phone so I do the same ones that I did with sixth period, so that everybody gets the same experience. But the idea with today is to try to make things a little simpler when it comes to dealing with these square roots that are just not so nice. And so it's kind of like part of 2.6, but it's an idea that exists on its own separately, but also can be used as part of us dealing with quadratic formula or even vertex form stuff, where you get these square roots that are not nice, and the numbers underneath might be kind of big. Like you've seen, we've dealt with like square root of 44, square root of 76. Sometimes we get these kind of really big numbers. And I want to show you how to make those numbers smaller, while also at the same time pulling out something nice. So that's what I'm going to do. I'm going to give you kind of a breakdown as to how to take those square roots that are not nice and make them simpler. Okay, so I'm going to call it simplifying square roots. Okay, so have this written down somewhere, and you can kind of just continue what you've been doing in 2.6, because we'll on Monday we'll put like yesterday and today together, right? We'll use quadratic formula, and then we'll make that square root simpler. Okay. Now, of course, if you get a square root that's perfect, just do it, right? Square root of 9, okay, 3. Square root of 25, okay, 5, right? Drop the square root symbol, change the number to be whatever that perfect square root is. And so this whole process is really more about, okay, what if I don't have a nice square root? How can I make it simpler? How can I make the number underneath smaller and maybe even get a nicer number that goes with it? Okay. Now, to make you believe in this process, it's a pretty short process. I want to show you that some things work and that some things don't. Okay, so I'm going to share my screen real quick and go to decimal. So I'm going to bring you down here so you can see me talking through it as I do it. Okay, cool. So I'm going to jump on decimals real quick. It's just a faster calculator. No graphing, really. I just want to show you the numbers themselves and how nicely this stuff works out. Okay. And then I'll actually work through a couple problems with you. You'll try a couple, just make sure you got it, and we'll go from there. All right, so I'm going to pull up this keyboard down here so I can draw the square root. Again, if you have like the square root of 9, that's 3. Right, done. I don't have to worry about simplifying the square root. I just take the square root, like square root of 36. Okay, that's 6, right? Because 6 squared is 36. So if you have those perfect squares, just take them. But if you end up with something like, okay, the square root of 8, right? That number kind of on its own, obviously, is not very nice. Okay. Now, what we do know about, and I'm going to back up a little bit, about a number like 8 is that it's the same as like 2 plus 6 or 1 plus 7 or 4 plus 4, right? They're all 8. But it's also, lots of negatives and whatever. But I don't want to deal with any negatives. I don't want negatives under my square root. And so the question really is, and so I'm gonna stop sharing here for a second. I probably didn't need to share just yet, but let me come back here for a quick second. Like, what do I do to make things simpler? So like, okay, 8 is, let's just pick one, 2 plus 6, right? And as long as I've got an equation that's true, and you don't necessarily have to write this down, I just want you to believe in what I'm about to do. If I add 3 to both sides, it should still be the same left and right? If I multiply by 5, as long as I do the same thing to the left as I do to the right, I should be good, right? If I square both sides, right, it should still be equal, which means if I take the square root of both sides, it should still be equal, right? And so the question that I want to kind of talk through with you is, can I, after that, then break that square root apart and do like the square root of 2 by itself and then the square root of 6? Like, are those the same? So that's why I put the little question mark there. Okay, the square root of 8 and the square root of 2 plus 6, all under the square root, should be good. And let's just make sure that that's true. But am I allowed to then break it apart from there? All right, so let's back up a little bit. Okay, so the square root of 8, right? Some nasty number. Now, is that the same as the square root of something like 2 plus 6? Well, yeah, right? Look at those decimals. Here, let me bring this down again. Right, those numbers obviously the same, which kind of makes sense because I just took the whole left side, took a square root, took the whole right side, took a square root, and I go from there. Now, does that mean that I can break it apart? Like square root of 2 plus the square root of 6. Are those the same? Look at those decimals. Totally different, right? And so that doesn't work. As much as it would be really nice, right, if I had a big square root and I had a bunch of stuff being added or subtracted underneath, that I could just break it apart however I wanted. Because then I could like pick perfect numbers like the square root of 4 or the square root of 9 or the square root of 16. I could pick perfect squares and then it would make all my stuff simpler, right? But clearly, that's not going to work. This number right here, yeah, sure, that's the same as this because it's just one big square root. But break it apart into separate ones, we're going to get different answers. Okay, so that doesn't work. I can't simplify square roots that way. I can't use addition and certainly not subtraction, like call this 11 minus 3. Okay, cool. Those are the same, but like the square root of 11 minus the square root of 3? Nope, doesn't work. Okay, so what can we do? And if we can't use addition or subtraction, what can we do? Well, let's try something like multiplication. What if, instead of writing it as two numbers being added together, what if I wrote it as two things being multiplied? Like, what if I took the number 8 and I said, all right, I'm going to rewrite that as multiplying two numbers together, like, I don't know, like 4 times 2, right? That equation's true, right? 8 and 4 times 2 are the same thing. And so just like I did, if I take the square root of the left and the square root of the right, those should be the same. And so the question is, okay, is that the same? So a little question mark right there. Like, could I break this apart into two separate square roots with the multiplication underneath? So I could deal with like the square root of 4 separately and the square root of 2 separately instead of trying to put them all together. Well, let's go back onto this screen real quick and see what the calculator kind of proves for us. At least, I mean, it's just an example, but maybe it'll give us some confidence one way or the other. Does it work or does it not? All right, so there's our square root of 8. Okay, so the square root of all underneath should still be the same. Cool, nice. There's that 2.828 blah, blah, blah. Now, what if I broke it apart, right, into something times something else, two separate square roots, 4 under the first one, 2 under the second one. There you go. Same exact number, right? Could I do, I don't know, like the square root of 60, right? Is that the same thing as saying like 6 times 10? Yeah, cool. So then can I break that apart with 6 and with 10? Sure, right? Same exact decimals all the way through. Now, the thing that I really liked about the first one, let me go back to that one. So I'm going to lose this one under here. I think we start to believe it. Like calling this 4 times 2. Look at that first square root. The square root of 4 is 2, right? No square root, right? I just took that square root. And then the second square root, okay, well, there's square root of 2, nothing I can really do with that. Look, exactly all the same. Which means the square root of 8 is the same thing as breaking it apart into kind of like two separate square roots where the first one is perfect. Right? When I broke apart the square root of 60 and I said, oh, that's the same as 6 times 10. Well, the square root of 6 and the square root of 10, there's nothing perfect about that. That's not one of my perfect squares, right? That's not 1 squared or 2 squared or 3 squared or 4 squared. No, those numbers don't help me. But call up the square root of 4 times the square root of 15, because 4 times 15 is 60. Well, if I could simplify this first one and just call it 2, and then just kind of hold on to the second one, nothing I can really do with that, a couple nice things happened. For one, I've had this nice number out in front here instead of everything stuck under a square root where I can't do anything with it. And the nasty part under the square root just got a whole lot smaller. Right? The number that I had to deal with is easier because it's smaller, right? For me, smaller numbers, easier to add, subtract, multiply, divide, whatever I need to do with it once I'm done with it. And so that's kind of what I want to do, is I want to take these kind of paths where we take a square root that's really just not so nice and we write it a little bit nicer, right? It's obviously never going to be perfect. But I'm gonna work vertically now instead, and we can actually call this one like number 1. We can take a square root that's not perfect and make it at least just a little bit simpler, right? So off on the side here, I'm gonna write a little how-to. So we've got some steps, because I know some people like me really like to have steps written out. Now, first things first, if it's a perfect square, then just take the square root, right? If a perfect square, then take the square root, right? Just do it, right? Take the square root, whatever it is. This is not for those, right? But sometimes we run into that. I don't want you to fall into autopilot and always do it the same way. If it's the square root of 25, boom, 5, done, right? It's if it's not, right? So if not, that's kind of what I want to focus on. And what we seem to notice, and I can show you thousands of examples that all work out the same way, that if I could take that square root and break it apart into 2 separate square roots, not connected by addition or subtraction, that one doesn't work, but connected by multiplication, then I give myself a shot, right? So if I take this square root of 8 and I break it apart into 2 separate square roots, I want to do it in a way where there's something I can then simplify, right? I want this right here, that number, whatever that number is underneath, I want that to be a perfect square that goes evenly into that number, whatever that is. So I want it to be the biggest one so that I can simplify it as most as possible. I want the biggest perfect square factor that goes evenly. That's why it's called a factor, because it goes in evenly. It goes evenly into that number by multiplication and division. And so when I look at a number like 8, I'm looking for a number smaller than 8 that goes in perfectly, that is a perfect square. And when I say perfect squares, I mean numbers whose square roots are nice integers, right? 1 squared is 1, 2 squared is 4, 9, 16, 25. I don't know how many of these nice perfect squares you know. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, kind of all the way down. I'll give you the first, 10 or 15. Let's see. 7 squared, 8 squared, 64, 9 squared, 81, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared, right? So, okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, kind of on down that way. 100 is kind of one that a lot of us maybe kind of learned up to, but after that, right, like 11 squared is 121, 12 squared, 144. Like I have this nice list. You don't have to have that memorized. And if you don't know those, take a second here in the next minute or two and jot those down so you have a list of perfect squares that right-hand side of that list, that you can always refer back to. Because the part about this that can sometimes be the hardest is to find that perfect number, right? What is that number that goes in perfectly into whatever number I've got that's also a perfect square, right? And then once we make that choice, like this choice right here is kind of up to this one, right? So it's just going to be whatever's left, right? Like for 8, the biggest perfect square that goes into 8, well, 9's too big, 16's too big. I'm looking for numbers smaller than that, right? The biggest perfect square that goes into that is 4, because 8 divided by 4 is perfect, right? No fractions, no decimals. But 8 divided by 4 is 2, right? I'm stuck with whatever that second square root is going to be once I choose that biggest one. And the whole idea of doing that is to put that biggest perfect square root first, because the square root of 4 is 2, right? Drop the square root, change the number because it's perfect. So I'm going to simplify or evaluate, whatever you want. I'm going to simplify that one, or whatever that perfect square was. But the second one, square root of 2, that's just the square root of 2. And so I'm just going to say bring down that one, right? I can't really do anything with the square root of 2, so I just bring it down. Use the dot in between or not. You really actually don't have to, because if you don't put a symbol between things, they're connected by multiplication, right? 3x is 3 times x. So 2 square root of 2 really means 2 times the square root of 2. And that's it. Really, so one step if it's perfect, and then just these 2 if it's not. Okay? And look at your numbers. A really nice 2 on the outside that maybe I can do something with, and I'll show you that on Monday. And the number underneath the square root, way smaller than it was to begin with. And that's always nicer for me to work with, so that if I can do something with it, I can deal with smaller numbers as that process goes on. Okay, so hopefully me kind of showing you the numbers on the calculator kind of proved it to you that it does work out really nicely when we do it this way. Okay, and I just want to show you a few examples. Okay, and then I'll give you a couple to try, and then we'll be out of here. So call this one number 2. I'm going to pick a square root that's just not on this list, because if it was, then I would just take it, right? I'm going to pick a number that does have that nice perfect square factor that goes in evenly, right? Now, if I'm looking at the square root of 24, my list is really only up to there, right? I can't pick 25, it's too big. I'm looking for numbers smaller. And so what I want to try to do, and draw the arrows like this if you want to remind you that you're breaking this apart, or not, you don't have to. You can just go right down to that next line where you've got the 2 square roots next to each other. That's always what I want to do. I want to break it into 2, not 3, not 4, just 2, where the first number goes in evenly, but it's also a perfect square. So tell me, help me out. What number goes into 24 perfectly that's on that list? So
2.
But 2 is not a perfect square. I want to be able to take the square root of that number. So I want a number that's on this side that divides nicely into 24.
4.
4. Right? 9 doesn't go in, 16 doesn't go in, 25 is too big. So 4 is my biggest perfect square that goes in nicely. Now, once I do that, once I pick 4, this number is set, because 4 times only a single number is ever going to get me back to that 24. 4 times 6 is 24. Okay, cool. So I split it apart. Biggest perfect square factor that went in and whatever's left. And now I just simplify this first one. Whatever the square root of 4 is, okay, 2, and just bring that down, right? Simplify the first one, bring down the second one. You'll never, ever change that second one as long as you've picked the biggest perfect square that goes in. That's it. You can plug this in the calculator, get some decimal, plug this thing, you're going to get the exact same one. So you can actually always check to make sure you're doing this right. Plug in the original, plug in the answer, get the same decimal. That's all there is to it. Okay, obviously the bigger the number, maybe a little bit more thinking kind of goes into finding the best number to break it up with. But there's always a best choice, and it's whatever the biggest one is. Okay? Yeah, let's do a couple more just so you see it. I'm going to go this way. And then I'll give you a couple to try so that you've got a little practice under your belt before tomorrow, because if you can do today's stuff, you'll be able to do tomorrow's stuff. Okay? So let's try it. Number 3. Square root of 50. Now, if that was perfect, I would just take it, right? If that was on that list over there, then okay, square root of 50, whatever it is. But it's not. It's not a perfect square. But if it has a perfect square factor that goes into it, I can break it apart and make things simpler. So, what number goes in evenly into 50? That's 25 square. Yeah, nice. What's left though? What number has to go right there if you just broke this apart with 25?
2.
Gotta be, right? Because 25 times 2. Addition doesn't work. Only multiplication or division, okay? Now that I've got that, now I just take the square root of the first one. And that's why I always put the first one, like the nice one first, because when I take the square root of that, my nice number sits out front. Kind of the not so nice stuff will sit at the end, just like when we did vertex form stuff where I always tried to put the nice number first, right? So, square root of 25. What is that?
Five.
Exactly, right? So I can drop this, whoa, I got excited. I liked it. I can drop the square root, change the number, right? I don't leave the 25 and I don't leave the square root. I take the square root of 25 and then I just bring down the 2. And I'm done. That's kind of just this in-between simplifying step that we'll do to make things easier. There you go. Another one. Just I want to show you one other thing that happens. Make sure I picked the right number. Yeah. The square root of 32. And this will be the last one I do with you, then I'll give you a couple to try. Okay, square root of 32. Look at my list, not on there. So I know I can't find a perfect nice number, but I might be able to break this apart into 2 separate square roots where the first one is perfect. What number that's on our list goes perfectly into 32?
16.
Definitely. Is there another one smaller than 16 that also goes into 32?
4. 2.
So 2 goes in, but 2 is not a perfect square, so don't worry about that one. But 4 does, and it's a perfect square. So here's the thing. It's like, do I pick the 4 or do I pick the 16? Now, let me show you what happens if you don't pick the biggest one, right? If I chose 4 instead of 16, the issue that we have is with what number is next, right? 4 times 8 is 32. Now, you don't have to write this part down because this is not how I want you to do it. If you don't pick the biggest option, the issue that we have when we take, the square root of that nice first number and kind of bring down the next one, square root of 8, that was the first one we did, which means that that one can be simplified even more, and I just doubled the amount of work that I have to do. Because, okay, square root of 8, oh, that's a square root of 4 times the square root of 2. That's connected by multiplication, and so was this, and now I've got 3 numbers all being multiplied together. I gotta keep bringing this 2 down with me. The square root of 4 is also 2, and then I got this square root of 2, and then I gotta multiply those numbers on the outside together. And look, 1, 2, 3, 4, 5 steps to get to here. When instead, if we were just smarter about our choice, and we said, you know what, the square root of 32, this is the one I want you to write down. The square root of 32 has a perfect square factor of 16. And if I choose the biggest one that goes in evenly, and then I just simplify that one, look what the square root of 16 is. 4. Square root of 2 I just bring down, and you just got to the best version of that answer twice as fast, just by picking the best one instead of the second best one. All right. Now, is it possible to make that mistake and still get to the right answer? Absolutely. Are there way more opportunities to make mistakes and it's a whole lot more work? Definitely, right? So don't do this one. Do that one. Okay, that's going to be your best choice. Cool? All right, 3 for you to try, okay? Because these will help kind of make sure that you know what's going on. So 5, 6, and 7. What did I like? 18, so square root of 18. Square root of 40. And the square root of 200. All right, try those 3 by doing this. Draw the arrows if you want. I'm going to stop doing that because we know what we're trying to do here. But just try those 3. Okay? What you'll see tomorrow is I will make up just a handful of these like these, but different numbers. And you'll just do the same thing. 2 steps. Break it apart. Simplify the first one. Bring down the second one. All right, so try those. I'll give you a couple minutes or even just a minute or so to get out in front. And then I'll write some answers down. And once you have gotten these 3 right and you feel good about it, then you can go. You see that over there? Get my head out of the way. There we go. All right, first one. If you got that one right, you're getting it. If you didn't, figure out why. Last 2 are up there. 2 steps, right? Biggest perfect square factor, whatever's left. Biggest perfect square factor, whatever's left. Okay, when you got those 3, you're good to go. Just check Canvas tomorrow for a little bit of practice like this, and then we will pick it back up on Monday.
Thank you.
Thanks, everybody.
Thank you. Thanks, Prezi.
Yes, see ya.